Okay, so hello everyone, can you hear me? Okay, just be waiting 1 minute, then we'll start the session.
Yes. While we are waiting, can I ask a question?
Please, no problem, please.
Now we have not touched any meteorological data, for example, like air temperature, humidity, or all this. We have not yet I reviewed all of the classrooms. You haven't touched on it at all. Although this is for us like basics, we need to call this meteorological data.
Okay, so meteorological data such as humidity or temperature for a
Correct.
long time.
Correct. Yes. Yeah. This is it.
Okay. So Google Earth Engine also provide this type of historical data such as air temperature or humidity or relative humidity. So this type of things we can easily access, no problem. Okay. So after completing the today's session, I also show you that. You can just remind me. I also try to show you that how we can easily access all of data. Okay, from that basically your hydrological data or atmospheric data, we can easily get it from here. No problem.
Yeah, that will be good. At least we have some records about it.
Yeah. Okay, I'll send you that. So basically, in Google Earth Engine, from all of data which are already available, we have to apply the same process for filtering, visualizing, or creating the time series chart. All of data set are the same process. Okay. So just I will show you that. I hope we can do it. And further, if there's any problem, then I also guide you. No problem.
Okay. I have another question before people join. Just to benefit from the time, because every minute with you is good. When we do for example, EFTVI or urban heat island, these values, when you put them in as data, sometimes it doesn't make any sense because you do you take a period of time, and then when you do the averaging and make the standard deviation from the mean or average, what is happening actually, because you have some cold nights and maybe warm afternoons and also some cold days. When you take this average, you find the urban heat island or EFTVI is really become very lean. And if you need to identify them, you don't find any issue with the numbers when you get the average values. Technically, how you overcome this, how you can tell this is good or bad area of urban heat island or something like that.
Okay. So basically, first of all, in satellite imagery, all time we don't get that accurate 100% result. It's not possible. Okay, because satellite capture the data for the different time. Okay. That it's very difficult to get the 100% accurate urban heat island or 100% accurate of LST is not possible. But we also get almost 85% or 90% currently data from that remotely sensed data. Okay, so this is the one region, and sometimes it also depend on our resolution. Okay, suppose when you is basically this is the 250 meter or 500 meter and also 1 kilometer resolution is available for the MODIS satellite imagery. Okay, so when you want to use the different types of MODIS scaling data, then we will get the different types of pixel value for LST or urban heat island. We find out the different result. So first of all, we have to try to use the very high resolution imagery. Okay, suppose now in present day, now we are also use the drone or also use the aerial photography to estimating the air temperature or LST, or LiDAR data is also available. So then we also get the more accurate result. And for basically when we work for the satellite data, mainly satellite imagery, this imagery is not captured at the same time. So that's why we are also use here the average. Okay, we calculate that all of images pixel, calculate the average pixel. Suppose I have the total 5 images, so all of images I consider and all of images, just I calculate the average pixel from total 5 images, and then I set the final result. But it also possible, suppose if you have only for the single day imagery, suppose you have a single day imagery, so without any reducing, without any applying statistical mean, max, median, without applying anything, we can get that actual value. Okay, it also possible, but for that we need the single date imagery. Okay, then we not need to put any kind of reducing factor, mainly mean, median, or max. We don't need. Okay.
Okay. So how you do the just in the code? I have to delete mean or maximum and it will work as it is, like a time series one.
So for the time series chart, so actually it's satellite imagery, so that's why we must use the reducing. Otherwise, it not work in Google Earth Engine platform. We must use the reducing because all of image is not captured at the same time. But it also possible. Suppose you just take the single date image. Suppose if the image is available for your study area, then you can also use it, and then you can get that actual value of LST or other. It's also possible. Okay, for to read the actual value, or any aerial photography, you also try different source. We can also get the aerial photography or LiDAR data. So this type of data we can easily use for that getting the actual value. But for satellite imagery, we have to use it reducing. Mainly, we have to use the reducer, mean, max, median. This type of thing we have to use. Okay. Okay, so I continue the class now, and further, if you have any question, you can all time you can chat in our WhatsApp group. So we also try to explore the different new things and also discuss about that. Okay. So basically, today is our 7th number of class, and today's session and some topic for the previous session is not completed yet. So that's why I also try to add this type of topic also in here. Okay, and then continue for the today's class, such as unsupervised classification. For the previous class, I did not show you that process, how can you apply the unsupervised classification for satellite imagery for classification. Today's session I'll try to discuss about that, as well as also change detection or hyper parameter tuning to improving your machine learning accuracy. So these type of things I also try to explain for today's session. Okay, so let's go try to start. Okay, let me share my screen. Okay, now can you see my screen? Okay, so let me connect my other device, then it also more better. Otherwise, it's also buffering some time. So okay, can you see my screen now?
You see it, but still no figures there.
So now I hope it's okay. Now it's okay. Okay, thank you. Okay, so now we'll continue. So first of all, I try to explain about that unsupervised classification, how we can easily apply in Google Earth Engine platform. So we already know about the supervised classification method. Basically, classification method we are already applying and also make the classification. We use the different types of classifier such as random forest or also classification trees or support vector machine. So now what's the difference between the supervised and unsupervised? So supervised classification method, we take this type of training sample for water, vegetation, barren land and build up. So we take this type of training sample and make the classification. But now when I apply the unsupervised classification method, then I don't take any kinds of training sample. Okay, so this is the main characteristics of unsupervised classification. In the unsupervised classification, we are not taking any kinds of training sample. So basically in unsupervised classification, how it will work? So it find out the similarities. Suppose all of water pixel have a unique properties. All of build-up, all of vegetation, all of barren land, every classes have a unique properties. So in unsupervised classification, we kind of ground truth data, it just find out the similarities and create the group. Suppose all of water, make a one group. All of vegetation, make a one group. All of barren land, make a one group. Not only for the water, vegetation, barren kinds of unique classes, it automatically create the group and make the classification. So that's why unsupervised classification is very important to work for different purpose, such as segmentation. Suppose you want to make the classification at the same time road, industrial area, then suppose residential area, this type of thing when you want to do, it's very used for the unsupervised classification, because unsupervised classification automatically make the distinguish between that industrial area or residential area or road or any other pixel. It automatically create the group. When you find out the similarities, it automatically create the group and make the classification. So that's why unsupervised used for segmentation. Purpose, suppose it also useful for the crop classification. Suppose you want to make the crop classification, you just apply the unsupervised classification, then it automatically distinguished individual crop and make the group. So further we can easily find out that this is the rice, this is the jute, this is the sugarcane, and make the classification. Because all time we don't get this type of data, such as ground truth data or training sample. If you have no any kind of training sample, then you can easily apply the unsupervised classification and you can easily make the segmentation or crop classification or any other satellite image classification we can easily do. So now let's check the practical example. I will show you that. So let me open the new code editor. Landsat or Sentinel both are in the same process. When you want to applying that unsupervised classification, we just apply the same process. So first of all, we are just need a satellite imagery. It can be Landsat or it can be Sentinel. Both of images are the same process when you making the unsupervised classification map. So just simply click on here and click on the browse data catalog. Want to work for the Sentinel, click on the Sentinel. Landsat is also same. For the Sentinel, I want to use for Sentinel-2 multispectral instrument this imagery. Just click on here, and when we find out this type of surface reflectance, it provides the more better result for land use land cover. So just choose the surface reflectance level 2A dataset for multispectral instrument. So this I want to use, and further I want to make the classification. So first of all, we need to make the image. Just we need to filter this image. We already know about that how we can filter. Just simply copy this image snippet from here, and then paste, and then give a variable name. You can put any name as a variable what you need. Suppose I put the name is that Sentinel-2, or you can put any name. Okay. After according to our region of interest, suppose where you need this image. So I need the image for the Dhaka city or any specific boundary. So simply where you need this image. So here I already imported my study area in my asset tab. So that's why I can easily use it. And then just suppose just import, and I put the name as a ROI, or you can put any as your variable. So now further, just collection where you need this image. For that we use the bounds with our study area, and then how you need this image. Suppose I need the image less than 1% cloud cover, so I consider all of images which is less than 1% cloud pixel percentage and set the value less than 1. Just put here that set the value for 1. Okay, after that just we apply suppose in this time after doing these things, when you need this image. Okay, it's for a specific time period, mainly where, how and when. Date function to put the specific time period. Suppose I put the time is the year of 2021, 1st January from year of 2021 December 31. So this is my time period. So after where, how and when, mainly filter bounds, filter metadata and filter date, I apply and filter this image collection for my study area. So now let's check how many images are available. Print the Sentinel-2, this variable, and available for this condition. We find out total 32 images is available, and this 32 images is the less than 1% cloud cover. This 32 images is available in year of 2021, and this 32 images is available for my study area in Dhaka city. So now composite median, mainly now from the 32 images it create the middle pixel value and make a composite. Okay, so just we try to make the median, or if you want you can also use the single date image. Okay, just copy the image ID and also use it. We already know about that, how we can use the single date image. So in this case I just use the median composite from total 32 images, and further clip with my study area, just clip with my study area RY. So now it display our imagery layer map dot add layer and call this Sentinel-2. Okay, and so map dot center object of your given area. Put here the 10 and click on. So now it visualize our satellite image for year of 2021. So this satellite image I want to apply the unsupervised classification. So just set the band combination for better looking for your imagery, and then suppose band 4, then band 3. This range is not reprojected. Okay, so because now it also have some scale. You can see in the bands it also has some scale. Scale is the same. You can see B1, B2, all of scale is the same value. So for getting the proper pixel value, we have to use this scale. Then we can get the proper pixel value. All of bands, all of spectral signature or spectrum value, we find out the proper range when I multiply with my scale. So just it also more better to use multiply with this. Okay. So now after run the code again, so now we can get the proper range of pixel. So now it reprojected the spectral signature. Further, just click on here. It suppose before red, then put here that green and put pressing again 8% for better looking this image. Just apply visualization. So now this it added the new line of the code in my code editor. After just copy the visualization parameter and paste after the object name. So this is my object Sentinel-2. Just paste after that. I put the layer name, suppose imagery. So this is my imagery, satellite imagery. After filtering, now I want to apply the unsupervised classification method. So in this satellite image, I don't know how much class is available. Okay, but when I apply learning, then I just choose my classes such as water body, vegetation, barren land, build up area, and make the classification. But for unsupervised classification, I don't know how much classes are available in my satellite imagery. For when I apply the unsupervised classification, how much class I got, I don't know. Because it's the unsupervised classification, we are not create any kind of pre-categorized data. But in supervised classification, we create as water, vegetation, barren land, build up, we create the pre-categorized data. But in unsupervised classification, we are not create any kind of pre-categorized data. We are not set any kind of value. 0, 1, 2, 3. Suppose here you can see when I apply the, I just put the 0, 1, 2, 3. But in this case, we are not applying any kinds of value. So let's randomly from this imagery, just I extract the pixel value. So randomly, not put any kind of specific for water, build up, vegetation, or barren land, not like that. We are just extract the pixel value randomly. So let's go try to extract the pixel value from here and then just make the unsupervised classification. For extracting value, just take a variable. I put the variable name, suppose sample, and now just I call this variable name because this from this image I just want to extract the pixel value. So this image is stored in this variable. This variable name is that Sentinel2. Simply copy this variable name and then further use it in here. And now I want to extract the pixel value randomly. So for that, use a function sample and put all of argument one by one, and then make a dictionary for start curly bracket start million study area. So just I put here it's a ROI scale is the resolution. I consider it's a 10 meter, and then number of pixels, it's not need about the projection factor, not need. Number of pixels, mainly how much pixel you want to extract from here. So in this case, I want to, it's not any kind of specific value. You try to add more than 50,000. Okay, more than 15,000 pixel we extract from this randomly. We extract from this imagery randomly. We are not create any kinds of pre-categorized data. Just we take the pixel randomly 15,000. So just I put here that 15,000, and others not need. Just I remove it. It's not need. That suppose I just print it. Print the samples. Suppose just I call this variable name samples size. I want to compute how much sample you can generate from this imagery. But it okay, let me check. Okay, samples. Just use the same variable name. Just copy and paste here and click run. So now it's computing how many sample we can collect from this satellite imagery. Not fixed. If you want, you can also use at 20,000 or 10,000 or 15,000 or 30,000 randomly collect the pixel of this imagery. Further, from the 15,000 pixel, now in this case I apply the 15,000 pixel. It means pixel. It find out that similarities. About the 0. Why? This is our imagery, and we are just have sample. Call our study data are that pixel number of size 0. 10,000 and check. Okay, sure about that. Zero number pixels. It means that it did not extract any pixel from here. Another argument, suppose I put the tile scale let me try this imagery. And set imagery, then check what happened. Okay, so now it's work. Yeah. So now it's work. So let me set the resolution again. Okay, we also reprojected the pixel value for the landscape imagery. Just copy the scale. just multiply and then add with offset value, then we can get that proper just copy this or add this as well. So now people run. And save the visualization. Just click on here. That screen. Pressing 98%. I also inform you later what is the problem for the Sentinel. Okay. Now it also okay for the Landsat imagery, which is also extract the pixel from 15,000 pixel extract from this imagery. Okay, it also work. But when I apply the Sentinel imagery, okay, so I have some modification because basically Google Earth Engine is all time every day they are updating their dataset or updating their new technique. So that's why I hope they also make some updating for their Sentinel imagery. Okay, so that's why now it's not work. But for the I also try what the problem and then I also give you the solution. So now it also work for that Landsat imagery. So here you can see we are just get the Landsat imagery and then further we are extracting the 15,000 pixel we are extracting from here. Okay, and we are not set any kind of pre-categorized data. So now using this 15,000 pixel, I just apply the clustering. Okay, clustering is one kind of unsupervised classification method. So this clustering helps you to find out the similarities between total 15,000 pixel and make the class. Okay, so now we are applying the clustering. Clustering is one kind of unsupervised learning. It helps you to distinguish total 15,000 pixel. And how much class I want to need, I also set it in the using the clustering. So let's go try applying this clustering and further just make the classification. For clustering, let's take a variable name. So I will suppose cluster, and then basically in Google Earth Engine, just if you search here for cluster, just search here. One kind of unsupervised classification algorithm. It find out that similarities between that. Also you can see cluster. Yeah. So here you can see different types of cluster function. So basically all of is the different algorithm for unsupervised classification. So this type of algorithm have lot of theoretical part. Okay, there are a lot of theoretical part is available. So that's why you also try to learn. You can easily search, then you can easily learn this type of algorithm, mainly how it will work. Such as cluster, you can see about that. So basically it's very popular cluster, this cluster, it's very popular. So in this case I want to use it and then make the classification. So here you can see about this argument, n clusters, mainly number of clusters, how much class you want to make the classification. It defined the n cluster. So just I simply copy this cluster from here, copy, and then paste here. Okay, and you can see that a lot of argument. I just simply ignore. I only put the number depend on you. Suppose in this case I want to make the total 25 classes. Suppose I put the 25. Individual total 25 classes. And I don't know about the class name. I don't know what is the class name. I don't know. So in the Google Earth Engine, when I apply the supervised classification, I know 0 is water, 1 is vegetation, 2 is barren land, 3 is build up. But in this case, I don't know what's the water, what's the barren land, what is the build up, I don't know, but it also classified. So let's check. We try to apply this. We find out the 25 classes, and this class name I don't know because we are not creating any kind of pre-categorized data. So apply this algorithm. Now put the cluster number 25. It's not fixed. Okay, so you also put the 5 or 4, then it create the 5 class, 4 class, 3 number of class. So now I apply the 25. It means that now this satellite image create the 5 classes. So let's go try to do it. And now I want to train it. So just put here the train function. I want to train it with my 15,000 pixel. I already create, just copy and paste here. Okay, so now this is my algorithm. This algorithm, I just set the number of classes, how much class I want to create, and I want to train using the total 15,000. This variable samples. Okay, so now this variable is stored my algorithm. So this algorithm I want to connect with my image. So this is my image, Sentinel-2. It is stored, this variable is stored my image. So now I just connect. So let's go try to connecting. Just take a variable name. Set the variable name, suppose cluster image. And now call this image. Basically this variable is that Sentinel-2. Just copy, paste here, and now I am to connecting. So this is my model. This model is stored in this variable, and now this model I am to connect. The previous class when I discussed about the supervised classification, for after creating, we are just applying a function. This function called the classification. Okay, so classify function we are applying to connect our model when I talk about the unsupervised classification. But now in this case, for connecting this model, this function called the cluster. Cluster function mainly connecting our model. So now just put here this your model. So this is my model. This variable is stored in my model, and just connect using the cluster function. So now this image to all of classes. So let's go. So for doing these things, just I add a layer, map dot add layer, and just put the cluster image I want to display on a layer, and further put here the color. Suppose I put the color mean. Suppose it will be start from the 1 and max up to 25 because I set the total 25 classes. Just put here. So now further you just simply randomly add some color because in this case I don't know what the class I got. So just put the plated and make some color plated. Suppose I put the color such as just set the color, and suppose I can put any color. Suppose I put the right in here. Suppose purple color. Then color or blue color, or put at that red color. So just they give some color, look like that. So now try to run the code and check what happened. So now it's loaded. Okay, so it creates this type of result here, you can see. Okay, we can get this type of classification map look like that, but we are not know about the class name because we are not create any kind of pre-categorized data. But every pixel have a cluster number. Suppose here you can see I just click on here in inspector tab and then click on this color. Suppose I just click on here. So now it provide me the cluster number. So here you can see this is the cluster 7. Okay, so this is the cluster 7 means that it's a class. This cluster number is the 7, and all of 7 number class have a unique. All of 7 have a unique class. Also, you can check about the other. Suppose just click on here. Just click on here. So it show about that class number here. You can see this class number is the 22. Okay, so he's indicating the another class. So now I don't know what is that. Is it water body or is it barren land or bill of area? I don't know. Also, you can suppose I click on here. So now it show me the another cluster number. So it show about that total 18. This is the 18 cluster number. So now from here I try to extract the information. Suppose I want to find out that water body from this classification result. Or not only for the water body, you can find out any kind of specific classes. It can be industrial area, or it can be any kind of properties on the surface. It can be any kinds of cropland or anything. We can do a lot of things using this. Suppose here you can see this is the one. This is the water body. I already know about that. When I click here, you can see it show the unique cluster value. This is the rate 22. Also, I know this is the water body because it's the lake of Kadirchil Lake in Dhaka city. So I want to check it what the cluster number for this lake. We can get the same number 22. Okay, so 22 is a water body. I know it from my previous analysis. I know it. So now suppose I want to make the water body map from this unsupervised classification map. So how I can make the water body map? Not only for the water body map, any kind of specific pixel you want to make the map. It can be an industrial area, it can be build up, it can be barren land, or any specific cropland, anything. I want to make the specific map from this classification. Okay, so doing this thing, just I take a variable. Suppose water. Okay, or you can put any name. Now I just call the cluster because this variable is stored at the land use land cover map, which is including total 25 classes. So just I copy the cluster. From this cluster, just set the unique cluster value. So in this case, I want to choose 22, which is indicating the water body. So just put equal 22. So it's a water body. So now I want to visualize this class water body. Just put here map dot add layer and call this water. You can put any name as a variable, and I set the color. Suppose mean 0 and max suppose 1. Now further put the plated. I set the plated look like that, where there is no water body, show as a gray color, and where is the water body, show as a blue color. So now let's click the run. So now it create the only for the single class map, which is including the water body, but it show a wrong. What's happened? Okay, sorry, cluster. Cluster image, so it will be cluster image. Okay, because our land use land cover map is stored the cluster image variable. Okay, this variable is stored the land use land cover map. Okay, just I simply copy and paste it, and further just display this. Just I want to add the layer. Just copy the same code, and now just write in here because cluster image is stored the full land use land cover map, which is including total 25 classes. So now from here I just choose only for the one class 22. So now try to run the code. Okay, so now we can get this type of water body. Here you can see where is water, and we can find out this type of blue color. It means that this type of water body map, and this water body map I generate from using the unsupervised classification. Here you can see we can easily find out the water from this land use land cover, which is including the 25 classes. So not only for that, any kinds of specific class. Suppose I want to find out, I don't know what the class about that, this color indicating about the this class. So I have to set it. So just click on the inspector tab and click on here. So now you can check about the cluster number. So we find out this cluster number is that also you can see about that 18. So I have to display these things. So just put here that 18, and I think it will be barren land. Okay, so just I choose the change the color. Suppose I put the color is that yellow. Okay, so now all of similar class show the yellow color, and we find out that unique class. So just let me open this layer. So here again we can find out this type of class is also available in here, also available in here. So it's indicating about that barren land, and these things we generate from Google Earth Engine. And when I export it, suppose just I export this full land use land cover map, then we can at the same time, when I import this map in ArcMap software or QGIS software, at the same time it visualize all of classes, mainly total 25 classes. We can easily get it from here. Also you can check, suppose this is the another, suppose click on here. We can get the 8. Okay, so I want to display it. Suppose just put here that 8, and I want to display it as a suppose red color. Click on. So now we can get this class as a red color in our map. So here you can see we can get this type of unique class. Okay, it can be any kinds of specific buildings or specific. Just it find out the similarities. This pixel find out the similarities and make this class. So now suppose I want to just put here the cluster number. Suppose just put here the total 5 classes. I want to make it suppose 5, and now applying classification and check the result. How map we can get it from here. So just try commenting this line, and now run the code again, and also put here that suppose 5. Okay, so now click the run. Okay, so now you can see we can create this type of total 6 classes. Okay, so it find out the total 6 classes in here. Okay, 1 to 5. 1 to 5 it create the total 6 classes we find out in here. Okay, we find out that, but in this time always we have to increase the cluster number. We have to increase the cluster number, then we can get the more better result. Okay, so we find out, suppose I just click on here, then we set it. Suppose we can get the cluster number, but always try to up to 25 or 20, then we can get the more better distinguish between the each pixel, and we create the more better land use land cover map using the unsupervised classification map. Otherwise, as you can see, it show this type of total. It create the total 6 class, but we are not get the more accurate. Okay, but when I put here more than 20 or 25 the cluster number, then it will be more better. Suppose just I put here the 25 cluster number, and also put here that the maximum 25, and click the run. So now it display the total 25 classes, and we can generate this type of map. Okay, and further from here you can easily find out that specific cluster value and set the class. Okay, so now any question you can ask me. Any question? Any question? Yeah, please.
Sir, then after classification, how can we differentiate between that it is a barren land or build-up area?
So for that we have also used some reference based map. Okay, we have to use some suppose if you want to see about that in the satellite, we can also get the base map. So from this base map we also take the decision Is it barren land, or is it build up, or is it water? Okay, we use the base map. From we can easily get this idea. Or SMS for the cropland also, when you want to for the cropland or any other classes or a specific building or industrial area, anything. Suppose here you can, so we can get this type of red color. So it find out the similarities between this red color pixel and make this type of classes. So that's why it's a unique class. But we don't know what the class about that. It can be, you can see, I think it's this type of vegetation or what about that. Okay, so it created the classification about that. Also you can see, and it also more better when you want to apply the Sentinel-2 satellite imagery, because it's the more high resolution than Landsat. We can basically for the unsupervised classification, always when we apply the better resolution imagery, then we can get the more better result. All time it can be, suppose very high resolution image, we find out the very good land use land cover when you apply the unsupervised classification. Okay, so now it Landsat for the 30 meter, so that's why we can get this type of result. Yeah. Also you can see it create another class. It find out this type of pixels. So just click on here and check the cluster number. You can see about the cluster is that we can get the total 25 classes. It's about the unique cluster number for these classes. Okay, it's working. Okay, just a minute. I simply connecting with my charger. Just a minute. Okay, so it's done. Yeah. Okay, so we can easily get this idea how we can easily apply the unsupervised classification in Google Earth Engine, and finally when you export, it's the same process. So now suppose I want to calculate the area, how much area is available for the water. Suppose I just make the class of water body, and then further I want to calculate for any other specific area, I want to calculate. Okay, so this is the same process. I'll show you after some time for calculating the area, because we also talk about the change direction also. So calculate area. So later we discuss. So now, okay, so anyone any question about that for unsupervised?
Sir, do we have accuracy also in this?
Yeah, for the accuracy, we have also used the reference base map. And further, we take the basically this unsupervised classification accuracy we do for that randomly. Okay, so randomly just we take the correctly pixel value and also find out that wrong pixel value. Okay, so and create the confusion matrix table. Then further from here we also calculate the accuracy also for unsupervised classification. But these things we are applying the randomly. It also possible to use the ArcMap software, QGIS software. Randomly we take the we just open the base map and then find out the correctly pixel and wrong pixel, and then further just apply the just you can, when you find out the Excel sheet about that correctly pixel and wrong pixel, then apply the formula and you can easily get this accuracy about that.
So can we get any videos?
Okay, I'll send you that, no problem. It also available. So just take this point and you can easily get it, no problem.
Okay, sir.
Okay, so this is the process about that, how we can easily apply that unsupervised classification and supervised classification. So now we talk about that change detection. Okay, so in Google Earth Engine platform, we can easily apply the different types of change detection. It can be land use, land cover change detection, or NDVI change detection, or any kinds of change detection we can easily apply in Google Earth Engine platform. Suppose here you can see it's one kind of land use, land cover map for Doha. So this map I already created using the supervised classification, mainly random forest. I already created for the 2-decade land use, land cover map. So here you can see it show about that one layer for LULC map 2023, another is the LULC 13. Okay, these 2-decade map I already created. So here you can see I already added the legend. So here red color identify about that build up, blue color identify about the water body, and then this type of gray color identify about the sand land, and red color identify about that build up. And this is the result for year of 2023. This map display the result for 2023, and also you can see 2013 we can get this type of map. Okay, so here you can see there are a lot of build up area expansion between these two time period, between 10 years we can get this type of changes. Okay, so now from here we find out that how much build up area increased, and we also calculate the change detection for 2 decades. Okay, so here you can see this is the result for 2013. We can get this type of result for land use, land cover, and also you can see about the land use, land cover 2023. So this same process you can also apply to create any kinds of change detection map in Google Earth Engine. So now we try to apply. So basically we just apply the 2 types of change detection. One is the single class change detection, another is the multi-class change detection. Single class change detection means that when I work only for the one class, suppose I want to just focus only for the urban area. Okay, I want to find out that urban change detection between these 2 time period. Then we can easily apply the single class change detection. But multi-class change detection at the same time, all of classes, I want to make the change detection analysis and also calculate the transition area. Suppose urban to urban, build up to vegetation, or vegetation to build up. So all of transition we also calculate it at the same time. So this is the process for multi-class change detection. So now I discuss about that how we can easily create this type of multi-class or single class change detection. You can easily apply this type of things in your own project also. So let's go. And this land use, land cover map, how we can create, I already covered for that previous class. So I hope you can take any satellite imagery and you can easily make this type of land use, land cover map. So now I talk about only for the change detection and then continue. Yeah. So here you can see we can get this type of, okay, so let me show you that one by one. So this is the code for, we already know about that, how we can easily make the land use, land cover classification map for using the random forest algorithm. We already create, you can see this is the 2 map. One is the classified, another is the classified one. So classified mainly it's the map for year of 2013. And classified one is the 2023. We are just creating the 2 variable, and further we are just stored this 2 decade land use, land cover map. So now I want to